Welcome to the first Nerfing Physics Optics video. Today we're going to talk about light and lenses. Look at your glasses if you're wearing some. Do you have a magnifying glass or maybe a microscope next to you? Perhaps find your camera. What all of these things have in common is that they have lenses and they manipulate light in such a way so that we can see things from the micro level to the macro level. But how do they work? How are these things able to manipulate light in this way? Why are they all made of glass or made of plastic? We'll find out in this first video of optics through my hands-on experiments at home. In today's experiment, we'll shine a couple lasers at glass blocks and lenses. And so we'll see how lenses work, how light bends, and we'll prove a law that is central to optics. There are really two main types of lenses. The first is called a concave lens, which, well, caves in, but it will also reflect light outward. A convex lens, by contrast, will bend out and it will reflect light inward. But how does this happen? Why and how do these two types of lenses bend light? Is it down to their specific shape or the material that they're made out of? Let's look at something else that really bends light. It's the prism. It bends light at the interface or the surface between air and glass, so light gets bent twice when it travels through the prism. Notice how the prism will always bend the light towards the base of the prism, or BC in this picture. Now compare the prism and the lens. They both manipulate light and they're almost always made of glass. What other connections are there? But do you see the similarity between the prisms and the different lenses I have in my drawing? Lenses just look like two prisms stacked on top of one another. The only difference is the orientation of these prisms. Lenses and prisms operate under these same guiding principles. Light will change direction between glass and air. But how does this principle work? To make things simpler, we'll do another experiment, this time with a single glass block. This time we'll also use our lasers again. We'll shine this laser through this glass block at different angles marked around the circle on the paper, passing through the center of the circle. But what do you see here? The same phenomenon appears and the light will change direction in the glass, which means that the material or the glass is causing the light to change direction, and the shape of the material, rather the lenses or the prism, controls where the light goes. But really fundamentally, what causes the light to change direction and by how much? Let's look at my experiment. I shone light at these blocks from an incident angle of 20 to 80 degrees, and I got a refracted angle of between 13 and 38. Well, the sign of the angle was interesting, let's say. Because when we divide the sine of the angle from the incident angle by the sine of the refracted angle, we get a quotient that's almost the same. I even plotted it out in the graph to show you how similar they were. Which means that we've proven that the sine of the incident angle and the sine of the refracted angle shown in this picture are proportional. In my experiment, the quotient between them was around 1.58. But really, what determines this constant? And how does this change between materials? We did an experiment with glass, but how does it work with other ones? Maybe water or diamond. This is actually related to something called the index of refraction, which is also related to how quickly light travels in these different materials. We'll pick up with this in the next video. Thank you for watching.